So continuing our 3.3 notes on completing the square, let's go ahead and try a few. So the first thing I'm checking is that our A value is 1, and it is. So move the C over to the right. The opposite of adding 4 is subtracting 4. Remember, this is going to create an open space for us to be able to complete the square. And 0 minus 4 is negative 4. I'm going to go ahead and add a blank on the opposite side here as well, because remember, whatever you do to one side, you also have to do to the other. So we take half of the b term, which is negative 3, and square it. Negative 3 times negative 3. I also add that positive 9 on the right side. So on the left, we have x squared minus 6x plus 9 is equal to, on the right side, negative 4 plus 9 is 5. So now we're factoring. We have 1 times 9 is 9. The factors of positive 9 that add to negative 6 are negative 3 and negative 3. So whatever your preferred method of factoring is, we'll get you x minus 3 times x minus 3 is equal to 5. Well, if we see the same exact thing twice, we can write that as x minus 3 squared is equal to 5. Oh, well, now this is just like solving using roots. I have parentheses and exponents. So we start with getting rid of the exponent. The opposite of a square is a square root. So this cancels everybody out, and we're left with x plus 3 is equal to, we personally wrote that square root sign, so we have a plus or minus, and 5 is a prime number, so I can't simplify it. My last step will be to add 3 to the other side. And remember, we're usually sliding it in there in between the equal sign and the plus minus, so there's no confusion as to whether or not the 3 is supposed to be inside or outside of our radical. And so this 3 plus or minus square root of 5 is our solution, root 0 x-intercepts. Example B. Again, I'm checking, is this number in front of x squared, our A value, 1? Yes, it is. So I'm going to subtract C, which is 1, to the other side. So I have x squared plus 4x. Created that nice empty space to be able to have a perfect square there. 0 minus 1 is negative 1. And then again, I'm going to go ahead and put my empty spot on the right side as well. Take half of the b term, which is positive 4. 4 divided by 2 is positive 2. Positive 2 squared is 4. Whatever I add to the left, I have to add to the right. So now we have x squared plus 4x plus 4 is equal to negative 1 plus 4 is 3. Let's factor. 1 times 4 is 4. The factors of positive 4 that add to positive 4 are positive 2 and positive 2. So whatever your preferred method for factoring is, you end up with x plus 2 times x plus 2 is equal to 3, which remember we can say, since I see the x plus 2 exactly identical twice, we write it as a square. The opposite of a square is the square root to start solving for x. So over here, that stuff all eliminates itself out to be x plus 2. On the right side, we personally wrote that radical sign. So we have plus minus. And then 3 is a prime number again, so I can't do anything to simplify it. Our last step is to subtract the 2. And again, we put it in between the equal sign and the radical 3, so there's no question as to whether or not it's supposed to be under the radical. So our zero root solution, x-intercepts, are negative 2 plus or minus radical 3. Our next one, again checking that our a value is 1, which it is. Now in this one, we're already missing the c value here. It's already been moved for us. So we can start with our empty space, keep that 12 on the other side, and we have our empty space. Half of b is positive 2. Positive 2 squared is positive 4. Again, whatever we add to one side, we want to add to the other. So now we have x squared plus 4x plus 4 is equal to 12 plus 4 is 16. Factoring our left side, the factors of positive 4 that add to positive 4 are positive 2 and positive 2. So we have x plus 2 times x plus 2 is equal to 16. And again, because they're identical, we can rewrite it as x plus 2 squared. Solving, I'm going to take the square root again of both sides to do the opposite of the square. It leaves us with x plus 2 is equal to, we personally wrote that radical sign, so we have plus minus, and the square root of 16 is 4. We're going to subtract the 2 over and put it right where we normally would. So we have negative 2 plus or minus 4. Well, wait a minute. The 4 isn't a radical. And so the negative 2 and the 4 are like terms. We can go even further with this. We can say negative 2 plus 4 is positive 2. And then negative 2 minus 4 is negative 6. And so our zeros, roots, solutions, or x-intercepts are 2 and negative 6. And our last example, again checking that our a value here is 1, which it is. We do have our c value of positive 2, so we're going to go ahead and subtract that to the other side, creating that nice empty space for us to have a perfect square. 0 minus 2 is negative 2. And again, I'm going to go ahead and add that blank spot, so whatever I add to one side, I'm going to add to the other. Take half of the b term, which there isn't a perfect answer for. So remember, we leave that as a fraction. And when we square it, 5 squared is 25, and 2 squared is 4. So we are adding 25 fourths to both sides. On our left side, we have x squared plus 5x plus 25 fourths is equal to, well, in order to add the negative 2 with the 25 fourths, we have to have a common denominator. So I'm going to multiply that negative 2 by 4 over 4 to get negative 8 fourths. So negative 8 plus 25 is 17/4. Well, now we need to factor. We need the factors of 25/4 to add to positive 5. And I'm wondering if you've noticed in the last 3 examples how we took half of this term, and that was positive 2 squared, and our final form was x plus 2 squared. And if you look back on the previous 2 examples, it ended up to be the same thing. So there is a shortcut to this factoring, which is that whatever you took and divided in half before you squared it is what actually ends up going into our parentheses for factored form. And so our factors are positive 5/2 and positive 5/2. We're again going to go ahead and take the square root of both sides to do the opposite of the squaring. We get x plus 5/2 is equal to plus or minus, because we personally wrote that radical. All right, square root of 17. It's not a perfect square, and 17 is a prime number, so it has to stay in the radical. But on the bottom, the square root of 4 is 2. Our last step is to subtract the 5/2 over to the other side, and again we slide it right in between the equal sign and the plus minus, and so negative 5/2 plus or minus radical 17 over 2 is our final answer for our zeros, roots, solutions, or x-intercepts. We're going to talk more about this shortcut and a few other things when we get back to class. So have that stuff ready and have a great night.